Hello, everybody. Welcome, welcome, welcome. It is a beautiful Friday, and I am happy to be here with you. This is our Versus AI Summit panel talk. This is training a gaming AI without, someone's just talking to me. A gaming AI without Google money. So it is I'm happy to be here. It's me, Drekken, your host, and I'm brought here with three guests. So why don't we go around the table and we'll talk a little bit about who we have here. First on let's see if I have my directional right or left. My left, Timo, from former software engineer, from the Deepmind team. He worked on AlphaStar, particularly in the environmental area. I want to make sure I get that right. And then above me, Kyotech, creator of Opti V2 from Rocket League. And to my diagonal box, to my left, Vlad, who's also on the Deepmind team, but specifically we know him from making Philip V2 from Smash Brothers Melee. Welcome, everybody.
Thanks for having us.
I am so happy to have all of you here. This is, I like to describe it where we're going across the AI multiverse to talk to different bot creators. And obviously people here on this channel, they know us for StarCraft 2 and specifically StarCraft 2, not because I have any bias against other games, just because that's all I know. That's all I've ever known. And one day I want to explore other games. So I thought this would be a great adventure across the different games and understand different challenges that different creators have. And so I'm sure, obviously, Timo, you can recognize from an idea that StarCraft 2 is a hard game to solve. And it's a very difficult game to solve. And by reaching across the aisle to different games, there's maybe a lot of things that we can learn from each other. And that's what I'm hoping we can have today in this talk, is kind of a chance to learn from each other, to talk about some of the successes and or even some of the ideas out there. So for you there in the audience, there's an opportunity to hopefully learn something. I know a lot of us here are hobbyists. We don't have those resources, to build, AlphaStar like bots, but I don't know about a lot of people here. That's my aspiration. And so what kind of shortcuts can we discover together to kind of get here? And so those of you in the chat, there is a mod. Magnus is in the chat, and he will be there to help. If you guys have questions, we're going to have a section near the end where Magnus will bring to you the questions to me, and we'll talk about that. But for the moment, let's do a little bit of an introduction of each other's and their bodies. I did the overall introduction. Why don't we start? We'll start with Timo. So Timo, why don't you give a little bit of, I talked about you, but I want you to talk a little bit about you, and then we'll go around counterclockwise.
Okay, so I'm Timo. I am a software engineer. I was at Deepmind for 9 years, and I worked on AlphaStar for 3 or 4 of those years. I primarily worked on the environment side, so getting StarCraft running on Linux, getting it working headless, getting the observations and actions all sort of complete. And in that sense, sort of supporting the AlphaStar team. I worked much less on the agent side of learning, but I interacted with them a lot. After that, I've worked on fusion and weather prediction, and before that, I wrote an MCTS bot that solved the board game. So I've been interested in the game space for quite a while.
That's fantastic. Awesome.
Yeah.
Let's Vlad.
I wrote PySC2, so if anyone's still using that was
I didn't. You wrote Pis. Okay, well, I guess that's a failure on my part. I should have known that. That is wow, that's actually really cool. Revelation for me here. I didn't know you wrote PySC too. I guess you know now in hindsight, Linux, and that made sense now. now in reflection. All right, cool. Vlad.
Yeah. I guess I've been interested in games and game AI for quite a long time, and even in like middle school and high school, I was like writing like little AIs for my games, and around 2016 is actually when I started working on Smash Bros. AI when I was still in grad school, and that was Philip V1, and that was actually pretty successful, and it's probably why I got the Deepmind job. And then I was at Deepmind for a while, and I stopped working about a year ago, and that gave me some time to work on Philip V2, which I guess we'll talk about in a bit, but that's also been pretty successful. So yeah, other than that, I've worked on like AI for solving math problems and doing some stuff also with large language models. Cool.
Cool.
Yeah,
Kyotech.
Hey, thanks. So yeah, I'm the odd one out. I'm not even a software engineer. I'm a electrical engineer actually. I kind of stumbled into AI a little bit. I was a Rocket League player for starting in like 2020. Just not good one. Just kind of enjoyed the game. I think it's a very interesting game for a number of reasons. But some folks made RL Gym, a OpenAI gym for Rocket League in like late 2021. And then they made a video about Necto, which was the first kind of good Rocket League bot, kind of champ level. Rolf and Soren and the community made that. And I saw that video and I was like, wow, that's kind of cool. That looks like fun. So I joined the RL Gym Discord, and I've been making bots for about 2.5 years now. Made a number of them over the years, but my latest is Opti V2, which is a hierarchical bot with some submodels and a selector model that, it's been relatively successful playing against humans. So, I kind of got into AI late, but I've been enjoying it, and I'm happy to be here.
No problem. And I just want to point out that there is nothing about the fact that you're not a software engineer. I think that's actually one of the best parts about this panel, where there is a level of where you can have a combination from different backgrounds, where a lot of times it is the interest in the respective games. Like I imagine, Vlad, for you specifically, like, are you a hardcore Melee player? Like, did you love Melee growing up? Are you a big Melee fan in general?
Yeah, that was probably the main thing I did in college. Was playing Melee. Yeah.
So I'm going to ask you. We're going to just jump off a little bit of the AI topic. Do you have your own GameCube controller?
Oh, of course.
Of course.
Yeah.
Now, how worn down is the nub of the thumbstick?
One of them is kind of worn down. One of them is a bit newer. Yeah.
Got it. All right. So
but I've gotten new. I'm past my like Melee everyday phase.
Okay, of course, naturally, and I think that kind of happens for a lot of people. Is that, at least for myself, I'm not a pro StarCraft player, but I love StarCraft. I've been in StarCraft 1 all the way up to StarCraft 2, a little bit of Warcraft 3 in between, and that was kind of a thing that just drew me to StarCraft in general, and then from there to AI. So I think that's that's a great place to start. I'd like to hear from everyone, kind of hear from Vlad, but what attracted us to gaming in general, and working with gaming AI, because obviously a lot of people can just be content with just staying in playing the game. But Timo, from you, were you a StarCraft fan in general, or was that just because of Deepmind specifically kind of pulled you into the StarCraft world?
I mean, I started programming with games. I always found it interesting to figure out what would make a good strategy and how I could automate that. And It always seemed like I could do better, or like program something better than myself. But StarCraft specifically, I played a little bit of StarCraft 1. I've played through the campaign of StarCraft 2. I've never actually played it much. But I did get pulled into the project fairly early. Like I was pretty much the first person on the project. And I don't think I actually ever played against AlphaStar, even though I definitely could have. You know, it was just, I always found it more interesting to be part of, you know, training the AI or figuring out the strategies instead of actually playing it mechanically with mouse and keyboard myself.
And Kaio, you said you actually played originally, and that transferred you over to actually coding it. And so, did you actually did you know coding, or did you teach yourself coding to be able to accomplish that goal?
No, so I've been coding off and on for, I don't know, since I was probably 15 or so. But like most of us probably, but I don't do it for a day job. I write scripts and things, Perl and Python and stuff to glue things together at work. But it's not my day to day isn't actually programming. It's more system integration type things these days. But Rocket League, the video popped up for me because I liked Rocket Sledge, the content creator. I was subscribed to him, so that's how I found out about the AI itself. And to Vlad's point, I don't actually play Rocket League myself anymore. Really, I play like maybe an hour a month these days, and that's being generous probably. And to Timo's point, I don't play my bots either, partly because they destroy me. It's not very fun to lose like 20-0, but there is a brief window in their training from baby to, you know, almost like top of the SSL level, almost pro level. There's a brief window there where I could play them and they would be fun, but I just I never get around to it. It's more fun for me to just let them play against themselves and benchmark them against other bots, and occasionally we play against humans, you know, in videos and show matches and things to kind of gauge their progress. But it's not that useful for me to actually play against it. I don't really get anything out of it except losing.
I mean, I feel like there's a general trajectory. A lot of people here is that we end up trying to make things that are better than ourselves, or at least that's how I've always kind of come across. Is like there's a level of, whether even that's specifically gaming and AI or AI in general, there's a level of something more than human. There's a level of, you know, more than human that we kind of pursue. And so always this level, you know, I've always personally struggled with this idea of like, why games, right? And it's just that challenge to push things further, and games really challenge people. And it seems like a really good test bed it's a really great test bed for AI in general. And so there is a level of I don't know, there would be a really good trajectory there to be able to.
Yeah, I mean, if you pick something like robots, for example, it's a lot harder to benchmark your robotic system against lots of other robotic systems, right? With games, you have this huge pool of people that you can play against, and kind of see how you're doing, and see if there's faults or cheese strategies that you're failing at and things like that.
Yeah,
that's definitely part of why Deepmind chose StarCraft, right? Like, we could choose a similarly hard game, but if there's no pro scene, it's unclear what it means to be good, right? You need something to evaluate it against. You know, if we're better than any human at a game that 100 people play, does that mean we're any good? Who knows?
Yeah, if you invent the game and then you're really good at it.
yeah.
But if no one else has tried to be good, you know, you don't actually know how hard the game is or whether you're any good.
Absolutely.
I think there's also there's an attraction too, especially to the fact that for us specifically, and I was hoping one of our guests, Peter, was here. The contrast what I was aiming for is that we have AIs in competitive games where humans play it at a very competitive level, and they push the game to those limits. And a lot of things as bot creators, AI creators, we try to find the exploits they don't exploit, or exploit their exploits, and find those elements that are missing. So one things I want to go around the table here. I'm going to do a little bit of introductions of the sort of the projects. And Timo, can you actually give us sort of for yourself I would say the most exciting moment of you when you were working on, or give us the story of the most exciting time on working on the AlphaStar project?
Interesting question. Maybe the first exciting part was way before any of the agent was there, where I created a UI for it, and having it up and running on Linux, headless, being able to interact with this game in a way that no one else had before, in a way that as if I was an agent. That was really cool. Later, we tried hard to get the RL, like the reinforcement learning training, working, and it just really struggled. It struggled for reasons like it didn't understand what it meant to move the camera. And so when we finally got supervised learning working, everything worked way better. And the agent could suddenly play a reasonable game. It wasn't fantastic, but it could actually play. And that was also an amazing moment of, holy shit, it works. We actually stand a chance of doing something. Whereas before, we were lucky if it managed to create a few hundred, I guess we were playing Terran at the time, so a few hundred Marines. But, the best strategy was still just probe rush or SEV rush right off the bat. That would win against the elite AI in like 10% of the games, and that's the best it could do. Yeah. When we actually took on TLO, that was also really cool. Just seeing this pro player come in, sit down, really confident, and then lose 5 games in a row. Yeah. The other highlight, I guess, would be when we played on BattleNet. And I guess not many people know, but we didn't automate all the things. And so, yeah, so we were playing 5 games at a time, I think. We had 5 desktops sitting in the conference room. I would connect to BattleNet. We would sit down, manually type the GLHF, and and it didn't know when to resign, and so we had to decide to resign. And so, it was way better than us. So our opponents would say, hey, like they would just leave if they were losing, but if they were winning, they would say things like, "Get out, you've lost," and because I'm no good at the game. I wasn't sure if they were just
trolling,
or if they had in fact won.
Yeah.
And so those are some of the highlights.
I love it, and it's very much like a Google I/O moment where it's like, man behind the screen kind of thing. I love it. Vlad, is there like a holy shit it worked moment for you?
Yeah, absolutely. I was thinking about that when you asked that question initially. It was back in Philip 1 back in 2016 when I was making my bot, and it was like, it was okay. I got it to like be the in-game AI, but like the next step was to have it sort of go to infinity with self-play, and kind of wasn't working. And at some point, I got distracted. I had some like grad school stuff I had to attend to, and I kind of actually just I'd forgotten that I'd left it running. And about a week later, I was like, oh, this thing's running. Let me see what it's doing. and I was like, oh my god, it's really good. It's way better than me. And that was like, it's like pro level. That was such a hype moment. I had so much adrenaline when I saw that.
And was there like when you was that you playing it, or did you like witness someone else playing it for that?
I was watching it play itself. I was just looking at, I had like
Oh.
a little feed into it, watching it play itself, and I was just like, oh my god, it is like, because I was good enough to tell that like it's doing all the like pro things, and it's doing them really, really well.
I think we'll definitely, if you actually, because I don't really, if for those out there, can you give maybe an idea of like what does it go from? Because I think and we'll probably come back to like in terms of StarCraft in general, because there's this level where it's just kind of derping about, and you're like, okay, this thing is kind of like not there, and then you're like, oh, it's actually there. And what for you was that indication? In terms of like,
I guess
like what it performed, or like,
I guess I mean, it was doing these short hop mirrors. I don't know if that means anything to. It was playing a Captain Falcon, and it was just doing them. It was like spacing them really well. It was like doing them so fast and so crisp, like kind of inhumanly, to be honest. But and it was doing a bunch of other, like it was moving like I think because I hadn't seen it train for 7 weeks for 7 days, I had no, because it was kind of just derping around, and it was good enough to beat the in-game AI, but the in-game AI is like really, it falls for all sorts of stupid things. So yeah, I had there was no like nothing to prepare me for watching it.
And then for you, like when you played it again, when you put it against a person, like what was the time when you had like the first time it went up against a human?
Yeah, so it was maybe a month later. Yeah, I brought it to a local tournament, and I had it play. I had it on a laptop and had people play against it, and yeah, it was. I was definitely like super nervous to see what it would do, but it was so cool watching these, like, because people were so skeptical, like, because for them like an AI was like the in-game AI, which is like it's it's really, really bad in Melee at least. So that's what they thought, and then they were like, oh my god, this thing's good. And then they definitely respected it after it beat a bunch of them.
I always love that. That's my favorite part, when you try to explain to, like, there's always two terms where you use the word AI and when you use bot. And so when you tell people like, oh, you're gonna play a bot, you're gonna play an AI, they're like, okay, sure. You mean like the one the one that you just put on the stock? Like, no, hold on, it's like a custom. It's a custom one. And they're like, okay, whatever. So I personally love that experience when, and it doesn't happen a lot in the StarCraft 2 scene. And for those who are out there or unfamiliar, just the scale, and we'll talk about this a little bit, the scale to get to that level of AlphaStar is just really huge gap. So a lot of times our creators will use some reinforced learning in parts of the bot and not all of it, just because it's more economical that way. But when you get to see the really awesome micro stuff, that's where it kind of throws people for a loop. And so for you, Kyotech, when you first got your, when you put Opti, I guess I'm going to ask, give us the story of, like, did Opti first get experience to like Rocket Sledge, or did you give it against the players? Like, what was the order of when you got that breakthrough moment for Opti V2 and you're like, holy shit, it works?
So Opti V2 was mostly incremental changes from previous bots that I'd had, but I had run it against some folks on my Twitch channel. So SSL is the highest rank in Rocket League, other than pros, obviously. And they're like 0.04% population, if I remember correctly.
Start challenging him.
So they're
if I
quite
jump there,
way better than I'll ever be. So I knew at that point, when it was starting to at least hang with that level, that I had actually made something pretty solid this time, because Opti V1 had a lot of issues. It never beat. So Nexto was the bot that was the king for a long time, made by Rolv and Soren and the RL Gym community some. And I didn't have the experience that Vlad and Timo did because I came into it late when there was already a gym set up for me, and already frameworks to learn from, which makes it a lot easier. But yeah, I mean, it was still seeing your first bot do anything is still very cool. Even when other people had already, I was late to the party, so other people had already done considerably better than that, obviously. But yeah, the first time it stops just kind of flopping around and actually, shoots the ball on the net, or something like that is still quite a moment, when you first see that from something that you created out of, neural nets might as well be magic. Essentially, they're it's for us humans, we understand the math somewhat, but it's a black box, and the behaviors that you get out of it are not necessarily what you expected in a lot of cases. And I loved Peter's video. Had a lot of that in it.
Oh, I love Peter's, and unfortunately he's not here because I'm and then we'll probably reference some of the stuff still, even if he's not here, because there's a lot of really interesting takes from there. But Kayatek, for you, with your, do you remember exactly the time, like the first time it beat somebody, like, or even let's say or scored on somebody? Because I'm sure players themselves have a reaction, like they have a sometimes visceral, maybe even when it comes to when this AI either beats them or takes a point off of them or takes a stock off of them or something like that. Is there like can you remember that moment for you?
I don't know that I can remember that specifically, but Opti is very
actually, was it Opti
heavy.
1 or 2? Sorry, that actually two. Like it was 2 that
yeah. So
got that,
Opti
that
2 is the one that one never quite, it didn't beat Nexta, which for me was a failure because I didn't have the best bot. And V2 isn't. There's Seer is out there, and Ripple's very good as well. There are other bots that are at that level of V2, but the Opti V2 is very demo heavy, demolitions, so it blows up your car a lot. And the SSLs that play against it it drives them nuts, which is just kind of funny to watch because they spend a lot of the game dead, unable to play, and they try to avoid them, but they can't because it's just partly it's the superhuman reaction time. Opti doesn't have any reaction time, which is a little bit of a cheat, obviously, and it has perfect information, so it can see. It's not using vision; it's using data pulled straight out of the memory of the game, essentially, and things like that. But still, to have these very, very good players who are better than I'd ever be, just kind of frustrated at the way they're getting beat, in particular. In one of those clips, there was a flip reset, which is a type of mechanical shot in Rocket League over an SSL, which just, I think, certainly for me, but for the RL Gym folks and the RL Bot folks, when they started RL Bot, that wasn't even dreamt of. I don't think that we would have bots at that level at some point.
I mean, I would say I would use the word delicious when that moment happens for me personally, when you're like, and then my bots are not done. I'll disclaimer here, my bot has not beaten a human. I have not come to that level, but I'm just the host, so I'm gonna give myself a free pass. But at the same time, watching, because I run here the pro bots, when I got to see one of the bots beat a pro player, so one of my roles is to introduce the bots that are in our community into the general pro community or the general player base. And watching that, I get like a little proxy high from that, especially when a pro player loses. For me, my favorite one was the player named Holy Hit. He's at Grandmaster, which for those out there who are from the other games is the highest, just below like pro, Grandmaster, and then pro. Most pros are Grandmasters. I guess it's like is SSL the highest, Kayatek, for?
Yeah.
Okay, so there's an equivalency there. So when a Grandmaster plays against some of the bots, we've had some pretty strong bots in our community, and when they get up against a Grandmaster and they kind of, I'm not gonna say snooze, but they kind of at first like, oh, this thing, whatever, and they underestimate it a little bit, and then the superhuman powers of the bot start to tax the human cognitive load, I would say, of the a lot of the players, because obviously, and you mentioned Biotech, there's a level of things that perfect information. And so in StarCraft 2, there's APM. And Timo, you guys in AlphaStar would have restricted your APM. That was kind of one of your things. In ours, we just let them have as much APM as possible, unhumanly possible. And so humans will react to certain things, but a bot can control all the individual units at once. And that just creates a little bit of, to me, I like to say it's like watching a ballet of units just converge on a human. So it's a little exciting. So
even AlphaStar did that early on.
Yeah, in the
It
earlier
was
days.
still only allowed to do one action every couple frames, but because it didn't have the camera and because it can select units more precisely, it did that dance with the what are they called? The Protoss one units, the early range
Stalkers.
ones.
Stalkers.
That's the one, and felt very unfair.
I mean, and I guess this is a fundamental question. This wasn't on my list of questions, but I really wanted to pose it to everyone here on this panel. Is the human restriction versus non-human restriction? So the idea of letting your AIs go beyond human capabilities versus constraining it down into what humans can do. And so pros and cons, or maybe positions. I'm curious to know around this panel, should our AIs be able to go past human limitations, or should they stay restrained? We'll start, Timo. Obviously, you have the most experience with restraining, so I'm curious, is that something you would have liked to see unshackled?
Well, so StarCraft is designed and balanced for human abilities. So I think if your goal is to compete against humans, you should try to play fairly, right? If you're just doing a bot versus bot, whatever, your rules are your rules. But if you're trying to play against humans, then you should kind of try to play by the same rules that humans play. And it's not that interesting to beat humans in a way that they couldn't possibly match.
Right. Vlad, it's actually, sorry, go ahead, Timo.
I mean, it's interesting to get there at all. If you can beat them without the restrictions, that is a good milestone, but I don't think that is especially interesting as an end goal.
Actually, why is that? Go a little bit further. Why do you, as an end goal?
Well, because it's not fair to the humans, right? They can't compete. If you want to claim you're better at humans at the things that humans do, then you should do it in a way that is fair to them, right? It's not interesting to run a marathon and then bring a bike or a car, right? Like, you're just gonna win.
I just find Vlad, let's hear from you. Oh, I'm hearing an echo. Let's just double check where that came from. Anyways, Vlad, your thoughts on that question?
Yeah. I mean, this is something I've been grappling with for a long time. The original Philip V1 had no reaction time, and
one of our guests showed up, but just keep going for a second, Vlad.
Yeah.
We'll introduce our other guest in a hot minute.
Yeah, so we're talking about inhuman abilities. Yeah, so
yes.
The original Philip V1 was just had no reaction time, and it was just basically playing a different game. Like you couldn't grab it because grab doesn't come out frame 1, and so it can dodge things that don't come out frame 1, which is almost everything. So it's I think it's not so unfair in StarCraft 2, but in Melee, where it's such a close range fighter, and you're like reaction time is so crucial. So I put a lot of work after that to have it try to play with human like reaction time, and Philip V2 plays with 300 milliseconds, which is sort of humanish, but it's still a bit unfair because it can see. Basically, because it's not using visuals, it can react to things faster than a human could. And so that's definitely, I think that's really important. A lot of players have said that, like, oh, it's doing things to me that no human could do. And I think it's sometimes those are really cool, but sometimes it's just like, oh, I can do this infinite combo because I can just react to all of your options, and you can't get out of it. And I think it's not that fun to play against, and I think it's not even that educational for a human. You know, if you're trying to figure out, like, what is the optimal play. Well, you can't copy a bot that's perfectly reacting. And I think one thing that's really cool to me is sort of seeing what, like, optimal play looks like, but within, like, the human realm of possibility. So yeah, I definitely think human restrictions are the way to go. And I also think it's kind of, in a way, it's, you know, until the robot is, like, you know, has a camera and, like, robot hands grabbing a controller, you maybe can't ever get all the way there. But I think going as far as you can is good, is the way to go.
Sorry, so Peter, we're actually getting the feedback. It's coming from Peter, Timo. We're coming feedback on your end, so just keeping it might be, if you might need a headphones or something, because we're getting, like, a little feedback from everyone.
Oh, sorry.
No, it's not you, Peter. Actually, it's coming from Timo, my man over there. Kyotech, I'm gonna bring that up to you, and then we'll kind of shuffle back down to Peter for a sec after what your thoughts on that.
Yeah, so I think Timo's point of a milestone is valid. If I get to the point where I am beating pros in all 3 game modes, 1v1, 2v2, 3v3, then I think the next step would probably be to add some reaction time. I don't know that I would go fully to the main things that the bot can know is it knows boost, which, if you watch the other players, you can kind of know how much boost they have anyway, because you can see when they pick it up and when they use it, but you wouldn't know exactly how much. And obviously we can't see the entire field. We have to swivel our camera. But a bot could swivel a camera fast enough to see the whole field all the time anyway. So do you add another level of delay to the camera to make it so that it can only process images as quickly as a human could process them? There's I don't know where you stop there, but I think there is a value to eventually adding some sort of reaction time at least. And there is another bot, Ripple, made by Rolv, does have reaction time, and is still very, very good, like high GC, which is right below Supersonic Legend SSL. And may even be SSL soon. It's actually very interesting. It's trained on replays mostly, so it's trained to mimic humans essentially, and then some reinforcement learning from there. But it's an interesting project, and he added the reaction time partly to make it more human-like because it's learning from what a human would do in that situation. The humans have reaction time, so it kind of makes sense to have the bot have the reaction time as well. But yeah, I think particular reaction time is probably the main thing that it's not quite as unfair as it sounds like it is in Melee. It's not, you're not automatically really good because you don't have any reaction time.
And I wanted to highlight from what I'm hearing from a lot of people is this idea of fairness. Fairness seems to be the core element that we want to really strive to do, is this level of being fair. Especially when going against humans. The restrictions themselves makes it a lot fun, or more fun, so I guess, for humans who are playing it. And so I'm going to put it up there, and we won't touch on this because I'm going to go to Peter for a sec, but this element of, and I pushed it to Timo, this idea of the goal that we're striving for. Is it optimum play within the confines of humans, or see what's possible within, like, I guess the game itself's field or ability field? But like Timo had brought up, the game is balanced around humans, specifically in StarCraft 2. But even the designers of the games that we build around, they're done with humans in mind, right? So a lot of interesting elements there, for sure. But Peter, you're here. Peter, for those of you there, Peter is the creator of, I don't know if your AI actually had a name. I just called it Pokemon AI, but everyone's AI here has a name, but we'll call yours Pokemon AI. But Peter, why don't you give us a little bit of a rundown? Really give it, we'll give it a little bit quick just because I want to be cognizant of time. But tell us about yourself.
Yeah, I'm Peter. Sorry for being late. Email was linked to a different one, and it causes like a 1 hour delay that I forget when they come through. So the password like only came through a few minutes ago. Sorry about that. But yeah, so I am I software engineer in the past. The last couple of years, I've been building my own kind of projects and things. I've worked in the ML space for a while, and have become more interested in like reinforcement learning. And that was this Pokemon AI was a project that was sort of a long-term sort of thing. I originally started the first experiments back in 2019 or something, and sort of on and off developed it until about a couple years ago when I sat down to like present the result of it because it seemed interesting. I think it's a bit different than probably some of the other AIs that you all have worked on or talking about, and that it wasn't trying to, I guess, like play like a competitive multiplayer game at like a competitive or human level. More is sort of in the space of like in a very kind of like exploration heavy kind of like open world environment, like how far can a learning agent like get, how much progress can it make with just like very simple sort of reward signals. So not as focused on creating some sort of hyper optimal play or strategy as much as just sort of that like kind of fundamental question is like, how much can an algorithm figure out in sort of an open world environment? I could talk more about certain things specifically depending what direction.
Oh, don't worry. Don't worry. I'm going to touch on that. And it's very important. And I want to bring up, Peter, you're right. You are the odd one out in the sense that your AI is more on a single player game, but there is a great contrast, I think, to the element of, first of all, the training that you did with your AI and getting it to perform in the way that you wanted. But there is a contrast between many of the bots here, which is to the aim to beat humans, and many were within the constraints of humans, but yours is a lot of the world itself, exploring the world itself and like pushing the boundaries of the world itself. So you know, we kind of had a little bit of roundtable already, but I'm gonna actually really want to get this question from you. Can you tell me the story of like an oh shit it worked moment for you when training your Pokemon AI? The story of that.
Yeah, there was definitely multiple of those for sure. I guess like when I first started, I was just sort of like, I was interested in like learning and designing algorithms, like reinforcement learning algorithms myself. So I started initially with sort of like very custom things, and like when it first started working a little bit, I was like, okay, but because it was an entirely new like environment that there wasn't any existing research on really, I was like, I need to like have, the result isn't really meaningless unless it doesn't have any meaning unless I have some baseline to compare it against. So at that point I was like, let's take some standard algorithms like PPO and see how they do. And it just started working really well. I think like definitely the first like big surprising moment was like after giving it just sort of pure exploration reward, just like novelty, like it's just trying to find unique screens. And like after running it for a while, like peeking at the screenshots and being like, it's like, oh, it's in like Viridian City and it's in Viridian Forest, and like I didn't even, there's no rewards that specifically tell it to go anywhere, but it's like, traveled a significant way through the map and navigated all this space. And I didn't really expect that it was going to be possible with such a simple objective. And definitely when I first saw that, I was surprised. Partly because like in the research, one of the things that was kind of unique compared to like, I guess like reinforcement learning environments that are used in research a lot, particularly in like the exploration side, is that like the like game length, the episode length is really long. Like a lot of times you'll see in research relatively short games where there might be like thousands of steps or something, but like like that progress might happen over something like, several hours or more, which is like a very, very long episode, a very long amount of time for like a game to last in the context of like training one of these agents like that. So that was surprising to see. Other moments that were surprising were in seeing it figure out certain things in battle, where initially, it's just sort of like it's using every single basic sort of move, and then when it has to like level up a while before it's like even like unlocked new moves, before it's learned more advanced moves. So it's like already reinforced this behavior of like, I'm just going to default to whatever the most obvious thing is. And it seems like it would probably just get locked into that, but given enough time and progression, it reaches a point where like once it actually levels up enough, it learns a new move, and there's still enough exploration that it does finally figure out that these new moves it learns are better, and it actually learns to like, once it's reached this point, it switches its strategy and it starts choosing different moves as it's deemed them interesting. So yeah.
Perfect. And we're going to get into some specifics actually as we get into, there's some questions I have about Magic Carp, but I'm getting ahead of myself. We'll bring that up shortly. But this is actually, this segues really well into talking about training. And I think this is, especially with a lot of reinforcement learning, training can be the biggest burden for a lot of people, getting their bot to perform. And so let's talk a little bit about training your AIs and then methods to either shortcut it or bring it down. And so we'll start with you, Timo, because obviously you came from like the largest project, and you yourself maybe not, but I want to hear from your musing from yourself. Is there methodologies from that you may have used about that could really shortcut the training time or to get results from? Because I think that's what a lot of people want to see. They want to see the results, get from starting to results. And so was there any element that really stood out to you that could shortcut that? Oh, wait, sorry, Timo, I just realized you're muted. My bad.
Okay, so supervised learning was clearly the thing that made a big difference. And like RL initially is what we tried. We had hoped to train AlphaStar in pure RL, and it could do stuff, but it got confused at the most basic things. And then you give it supervised learning, and suddenly it was, okay. It could play a reasonable game. It could move the camera. It could, try many different strategies successfully. That was definitely the biggest sort of jump. The other thing that made supervised learning so impactful was not just that it could suddenly play and relatively quickly, but we could iterate way quicker. And so we could, with RL, we would train a population of 10 agents, and 3 of them would crash, and a bunch would be somewhere in the middle. And you take some average of that, and it tells you your average win rate against the built-in bot is 10% or 20% or whatever the number is. And now you train exactly the same thing again, and now it gets 50%. So there's no way to tell whether your change is improvement or not. You now train this in supervised learning, it trains quicker, and it always converges to the same thing. So you make some improvement, and now it goes from 50% to 53%, and that's a real change. So supervised learning was definitely the biggest speed up we got.
Now, was that because, and I'm sure many would have wondered this in the audience, is that a lot too because of you guys had like a narrow defined goal and you wanted to achieve it, and supervised learning was just the best way, or was it just reinforcing learning? There wasn't a path forward that you may have felt that was possible?
I mean, Google has a lot of money and a lot of compute, but even we have limits. And we used a ridiculous amount of compute, but I'm not sure all of the compute in the world would have been enough to train to AlphaStar's level if we had started from nothing, especially early on. And that's partially just because StarCraft is relatively slow as a game. We got 200 frames per second or something, but not a million. And because the action space is just ridiculously huge, and the space of strategies is really big, and some of the things that are needed to learn are just hard. And so we wanted to do a straight from RL, but it's just a lot easier and a lot faster to start from supervised learning, where it has at least reasonable strategy that it can start with and learn the basics of what a camera is, or what it means to win, or what it means to build an economy. These are all really hard when you start with a few workers and you're 10 minutes or 3 hours away from winning, and nothing you do gives you any reward at all.
Yeah, for sure. And so, sorry, I just got a quick message, and there's still a little bit of feedback coming from you. Yeah, so it can be a tough thing when it comes to figuring out the rewards and stuff like that. And so, just in the absence of time, when it comes to, from your stuff, let's go with Kyotech. When it comes to training, was there a shortcut for you to cut down the training and making the training work out easier?
Yeah, I mean, rewards tuning is king in Rocket League still. We're not here to do science. At least I'm not. Maybe some folks are. I just want to make the best agent I can. And people have tried, and I've tried, sparse, goal concede only, just score a goal or get scored on. Those are your rewards. And it's a big ask. It's a long way from there to play in the game. There's a lot of actions. The games are long. The ball doesn't even move at first. Right? If none of the agents touch the ball just sits there. So they don't even know that the ball is involved in the game at all. It's that the ball is pretty important to the game of soccer, and they don't even realize that it's a thing. So yeah, I mean, we have a lot of rewards, and a lot of tuning goes into the rewards, and engineering goes into the rewards to try to get them playing something more closely related to the game. And that first step is hard to get them start playing the game. It's not hard anymore. We've solved it, but from there they can start playing against themselves and learning a little bit more easily. But until they get to that point, there's not a lot. The exploration is very poor. I was amazed at the exploration that Peter got out of PPO. Honestly, I would love to get that sort of exploration out of any of my agents. But yeah, I mean, reward tuning and start with something small and solvable is the other thing, especially if you're tackling a new game that hasn't been done, or if you're changing your algorithm or changing your framework or something like that. Take a little piece of it that should be solvable in a reasonable amount of time, and make sure that the agent can solve that. Because you've got this black box that you send data into, and you hope that good things come out of it. But if you have bugs that you don't know about, you could train for months and get nothing, when it really could have learned it in a few days if you had actually just tested things properly. Like I had OptDV1 didn't know which direction was up. Actually, there was a bug in my observation space, so it never knew its orientation up and down. And if you go back and watch some of my streams, you'll see me chatting about, why will this thing not land on its wheels? Why does it keep landing upside down? Why are the rewards for landing on its wheels not having any effect? Why does it not land on its wheels? It's very simple. I'm telling it this way is up, land this way. And it's because it couldn't tell. The observation was broken. So it had no idea which direction was up. So yeah, test your stuff, and rewards are the key though, to what we've done in Rocket League anyway. Simplify it gives the agent a signal to follow, right? Without the goal concede, the sparse rewards are just it's a very weak signal to try and follow.
Cool. So actually, I'm gonna tie into Peter first, and I'm gonna go back to Vlad. But Timo, Peter, I feel like rewards was some of your jam when it came to your Pokemon AI.
Yeah. A big part of that project was just sort of like studying kind of the effects of the rewards and trying to introduce them incrementally, and even like optimizing it for simplicity in some ways. It is like challenging to with rewards as like a hyperparameter. It's more feasible at the scale of something like Pokemon, because you can run the training on a single machine and you can like see the result of an experiment in hours or something. But the bigger the scale, the more the fewer chances you get to like do a training run changing a single variable to see isolated how some change affects it. And the like hyperparameter space, especially when you consider all the possible reward designs, is just so vast that like it's very tempting and easy to want to make multiple changes at once, because you just can't run that many experiments, and you kind of like sometimes it's like, well, like let's throw in 5 rewards that seem like they make sense and see if there's an improvement, because
it feels like a disaster.
Combination of adding every single one to know what their effects are is just like there's only so much time and compute in the world. And there's some work right now in an academic. We're working on a paper, and it's kind of the strategy, right, of rather than like building it up one thing at a time, throwing a bunch of things at it, and then going back and like ablating them off, which is maybe a top down rather than bottom up sort of approach to designing the rewards sometimes. But it is interesting for sure to just sort of like see what behavior gets induced when you're working with just like different simple rewards and the behaviors that come out of it.
Absolutely. So, and then we'll touch back on Vlad, what would you have done to either have scoped out or to really reduced the amount of training time? I'm first of all, I'm very unfamiliar with what kind of rewards you would do in Melee. So if you would touch even on like the rewards you to get it to do, even a back air, like how would you tell it like back, bear is good, or like down air is good? Like I would love to hear how Smash works in that regard for rewards.
Sure. Yeah. I mean, Smash is it's probably the easiest game out of all the ones we have here, because you and
more than Rocket League.
What's that?
More than Rocket League? I don't know. A ball.
Well, at least from the point of view of rewards, I think basically from the beginning, the only rewards I used were KOs and getting KO'd, and dealing and receiving damage. And so, yeah, I mean, you just have to bump into your opponent and use a move, and you'll get some reward or lose some reward. And that's pretty much all I've used the whole way through. And so, yeah, it just learned that certain moves are good, certain moves are not good. Being off stage probably not good. And as for how I would have done it faster, I don't know if that was part of your question.
How would you kind of, I guess, reduce the amount of compute you used, or the amount of to train on? Like, how would you have maybe been a bit more efficient in training? if you did it over again?
So just to say, I think it's efficient enough. It's like I can train on basically one machine, and I can get a really strong agent. Maybe, well, it takes a few days to a week, but it's not like it's not too bad.
I'm envious.
Yeah.
I'm crazy envious.
Yeah. I mean, I got like, I mean, I had some help from like some Melee hackers who basically hacked the game itself to run faster for me. They added some like assembly codes to shortcut some of the game's logic that wasn't necessary. So I'm hugely grateful for that.
And that sped up the training time, I guess. Like probably how much percentage would you say?
Sped it up a lot. Yeah. I mean, it's probably running like, well, it's hard to say exactly, but it's probably running like 2 to 3 times faster, just the emulator itself, which is pretty nice. The other thing I'm just gonna reflect 2 things actually. To Timo, Timo said like supervised learning. So the main difference between Philip 2 and Philip 1 is that I added supervised learning from replays in, and that that just made it play way better, and that's actually what made it play with human like reaction time way better. Because it was really hard to get reinforcement learning to play with reaction time. That was something I found. And then the final thing I'll say is like, testing. To be honest, Philip V2 would have succeeded a few years ago if I had better testing. Like I had a bug in my reinforcement learning like math that set the discount rate basically to 0, and so reinforcement learning just wasn't working, and I didn't know why. And that's a tough thing with these like ML things, is that like you don't know if it's not working because you have the wrong ML algorithm, or it's too hard of a problem, or you just have a bug that sets your learning rate to 0. So, yeah.
I mean, it goes straight back to Kyotek says like the black box element, and man, first of all, I'm gonna say I'm super jealous of the one machine record thing, but actually I wanted to bring up to Timo, and I'll feel, if I'm shortcutting a lot of questions because I want to be cognizant of time. But Timo, there's been a new paper that came out about AlphaStar Unplugged, and it comes about training agents from replays and having that element where offline replays or using as a human replays as a data set. And do you feel like would that have changed a little bit of how things would have gone in reflection? Because I'm hearing a lot from Vlad, or even like using replays to kind of really change the game a little bit for getting there faster. From how would the AlphaStar Unplugged concept have changed how our approach could happen if someone was to start today? Oh, you're still muted. I apologize, Timo.
I actually wanted to reflect a little bit on the reward idea first, which was that even in StarCraft, initially we trained on win-loss, but what we found worked way better was having the reward come from a supervised agent, or a supervised, I guess they call it a baseline, that can see both sides. So even though there's fog of war in StarCraft, so you can only see your units and some of your opponent's units if they're near yours. But if your reward comes from seeing both, like it has the God's eye view, and it can see, you have a unit composition that can win, or you just have a lot more, even if you can't see what the other one is, and you get rewards for that. That gives you a much denser reward signal and a much truer reward signal than if you're doing it from only your perspective. And so that really helped us as well. As for AlphaStar Unplugged, I'm on that paper. I wasn't involved with it too much, but read it again today, and I'm sure that would have sped up our training. It's unclear to me how much it would have sped it up. Right? The supervised learning already trained in only a couple days, and got to 84th percentile human. So like, what's that, Diamond League? Maybe Masters?
Yeah,
somewhere
roughly.
And it looks like the AlphaStar Unplugged, despite the fact that it was never played on Battle.net, it did significantly better. So I guess that would have been solidly masters. Maybe that would have cut a couple days off our RL training. It's unclear that it would have led to a higher peak, but it certainly would have trained faster.
Cool. So I'm going to open up quickly to the floor. Anybody here, before we move on to this topic, anybody wanted to drop anything left on the idea of training, specifically on cross floor? If there's anybody's point that you wanted to touch on as well, I open it up to anybody. I won't.
So one of the other complexities in StarCraft, which is mentioned in a bunch of these papers, is there's the rock, paper, scissors dynamic of, our agents, especially early on, before we did supervised, they would learn to do a rush, which would be beaten by defense, which would be beaten by macro, which would be beaten by rush. And, that's why we came up with the league and what made everything so expensive to train, but also is what made it work. StarCraft's just really hard.
Absolutely. We're going to talk a little bit about trade-offs and into getting it. And so we'll start specifically with Kyotech. I know you used submodels with it. And so was there are there any key trade-offs when it came to using submodels versus maybe a single comprehensive system?
Yeah. The main thing is it's hard to make the what I call the selector, the high level bot. I've been struggling lately to get that to make good choices because maybe because all the submodels are kind of good at the game now. That's one difference from OptiV 1 is that all of them can play the game. They just play it differently. But the pro is that there's a lot of mechanical moves in Rocket League, like flip resets, where you're not going to find them out randomly. But they also, eventually you will, given infinite compute, but they are... I was struggling to have an agent that would do multiple things well. And there's a lot of the moves in Rocket League are not related to each other. They don't play well off of each other, so they're kind of distinct styles. But pros can do all of them, right? They're all moves that you need to be able to do to play at that level. So that's what led me to splitting the agents and then trying to put them back together at the end, is that to get that get those specific moves that you kind of need to be able to play in one agent eventually. But my OptiV 3, I think I am going to do a bit of a all at once kind of train all the submodels and the selector all at once and let them kind of battle it out, a little bit of a Alpha League situation, see how that works. There's a new framework that someone has written that will make that possible. Thanks JVK for that. He's done a lot of work on my other PPO modifications to allow selector to work as well, because one of the other issues I ran into is that the time scale on Rocket League is long for a lot of these moves. You need to do the same thing for maybe 3 or 4 seconds. And if you do one wrong thing in those 4 seconds, you screwed up the move. And you end up missing and getting scored on. So I kind of forced the agent to stick with that one move, essentially, for some period of time during training. And then I kind of ramp that down. But that broke PPO a little bit because the state, it didn't actually come from the action that it chose now. It came from the action that it chose a while ago. So he did some math to kind of try to fix some of that for me. But yeah,
absolutely. That actually reminds me, and you wanted to, is like the AlphaStar League, the element of just having these different subagents and basically combine it into different pieces. And I don't know, Vlad, I actually have the least amount in terms of your training method. I don't know, is there anything that you might be able to hit on how you train to get your Philip V2, like from Philip V1, I presume you mentioned that it was the change of supervised learning, but was there a particular method that helped you get it to the level of being able to take on a person better in terms of skills or abilities?
Yeah, not sure I completely understand the question, but
sorry,
yeah,
because I have very little bit. So actually, maybe you can give me a little bit of an idea of how you get Philip V2 to where it is.
Yeah, I mean, it's very much in the AlphaStar model of like first do supervised learning. So the reason I started Philip V2 is because suddenly replays were available starting in around 2019, 2020, and so yeah. So step one is train it to play like a human, just imitate the human from the replays, and then step two is do reinforcement learning. I'm using PPO. Same as some of the other guys here. And yeah, I mean, I did some hyperparameter tuning, but it works pretty well. I will say that this issue of like the rock paper scissors does show up in Melee as well. Oh. I think that it's a really partly because of that reaction time. Basically, the reaction time gives your opponent time to disguise what move they're making. So right. I pick rock and you pick paper, and then 18 frames later we find out who wins, and that's happening all the time. So that actually makes things quite complex and interesting, and that is a weakness of traditional RL algorithms, is that they kind of just always focus on one strategy, and so one of the next things on my list to do would be to try to implement something like an AlphaStar League to try to have it play different strategies and then disguise what it's going to do. Yeah, exactly.
And then Peter, and for you obviously have had probably with a lot of with your AI exploring with RL and bumping into it the world, specifically with your video touched on the Magikarp, the purchasing like of what was it, like how many Magikarps, like 1,000 Magikarps.
Yeah, I think in like a full later training run, basically, yeah. Once it like figures out how to do it, it basically does it every single game. So if it plays thousands of games, it's going to do it thousands of times. Yeah, that's one of those I guess like misaligned rewards where if you do the simple thing and give it the incentive for gaining levels, it's a good heuristic for most of the game, and then it reaches some new point where it can do something. I mean, it's not really like that detrimental to the policy overall, but it's not like super optimal probably. It's going for it based on the fact that it's just getting free levels from it.
And then when it comes to because I know that you had different versions, but you didn't break them into different submodels, I presume. It's like it was different training iterations for yours. What was it? You might have to jog my memory, but you had different training iterations over and over again for getting it to get past Viridian, not even Viridian City, but after beating Brock and whatnot.
Yeah, I tried to sort of like simplify in the video the like process of my experiment iterations and like the agents learning by sort of like overlaying them on top of each other and showing like the agent's progression with the design of like the training run together in the actual process, right? It's like every time there's some change, it's like re-going through the whole sort of like the whole training process and starting from scratch. My recollection, I think, of like the AlphaStar stuff, I think that, correct me if I'm wrong on this, but it was like maybe prohibitively expensive to start from Scratch often on that, so it's more important to be able to do the model surgery or things to be able to reuse a trained model, I think. Whereas, yeah, that wasn't. I mean, it would be nice, but it was able to get by with that too. Just restarting from scratch with each change.
Absolutely. Timo, I could clarify too, is that you guys did not start from scratch each time, I presume.
So I'm not sure how many times we trained the supervised model, probably dozens. Full RL, we probably trained dozens of times as well, but not to a full level, right? Like we'd stop after a day or so, and probably start with much fewer compute resources. The full final one that we only trained once, and we could very much only afford to train it once. Yeah.
Cool. So we're gonna just go around for a few questions, then we have some questions from the audience, which we'll go through. Before someone starts a project, what would be one question you think people should ask themselves before they start a project like this? We'll start with Peter. We'll go with Peter and we'll go around.
I guess like one thing for sure is like what exactly your goals are. Like, are you trying to create like the best agent that's going to like outcompete humans? Are you just trying to learn things? Are you trying to like advance a benchmark on a game that already has like existing work on it, and like what your goals are and your resources and time that you have available to put at it, like will shape what is possible or what is feasible, what is reasonable. I think that like it is possible to do like some tinkering without like having a really like deep understanding of RL and ML, but it will become progressively harder to like debug and like really like have the intuition, because that's kind of the funny thing about these like highly emergent algorithms is that the whole point is that you don't have to understand what it's doing, but then simultaneously the flip side of that is when it's not working, figuring out why it's not working and then being able to fix it is as difficult as it could possibly be.
And I could totally put a whole segment on talking about like getting past that problem. I'll keep that in mind, pinning that for another time, because I can imagine there are many ways to stumble in and out of those situations. Timo, thoughts? What do you think every gaming AI creator should ask themselves before they get started?
I think what are the smallest ways of starting? So we started wanting to do pure RL, and we started on a map called Simple 64, or even before that on some mini games where the goal was just to control 2 units and do pick up a bunch of minerals or just mine a bunch of stuff. And if your algorithm cannot do these trivial things that should be solvable, on a single machine in a day or two, you're going to run into those problems when you try to scale it up. Yeah. So you need the simple benchmarks, the simple test cases to even get started. Especially if you're trying to tackle something like StarCraft, and you're trying to replicate AlphaStar, you need to be a little bit more realistic that this was a team of 20 of some of the best RL people in the world with the most compute in the world, and it still took 3 years. Right, and I think there is a much smaller version that you can do that will get you 80% of the way there, and that should be the goal, not to actually replicate AlphaStar, because I don't think that's realistic for anyone in the next 10 years, maybe even more, just because compute is too expensive. But training a supervised version, AlphaStar took, like the supervised took us 3 days, and I don't know how many GPUs it took us to train that, but the curve just goes straight up, right? You get to 80-90% of your asymptote in like 3 hours. So it's entirely possible that someone with a 4080 and who's downloaded 10,000 or maybe 100,000 replays can get to 70-80% of AlphaStar supervised in a week or two of training at home. That seems totally reasonable. It's not going to be AlphaStar level, but it might well be the top on the leaderboard. No one's done it as far as I know, but I think that's doable. And I think there's even smaller versions of that, like only train the build orders and leave all the micro and unit placement and all that stuff to a scripted version. Blizzard actually did this. They did it as a like hoping to put it in the game and teach people how to play by suggesting you should, you're about to be supply blocked, maybe you should build a pylon or whatever it is. And they never actually released it, but they did this on their own from 1,000 replays or something small, and it actually gave good suggestions. It would not surprise me if that would get you halfway, 3/4 of the way up the leaderboard alone.
I heard about that secret project. I thought it was just a rumor, but you've confirmed it here for me. I heard about it as a secret project. I was told by some of the people who actually had worked on it because they had suggested to Blizzard. But the first time I've ever heard it spoken out loud. So that's exciting. That would have been a cool idea. Wow. Same question I'll say to you, Vlad, and then to Kyotek. What is the first question someone should ask themselves before they get started?
Yeah, thanks. To be honest, just to piggyback off what Timo was saying, I'm also really curious about like the StarCraft 2 and has that been done, the supervised StarCraft 2 bot? Because if I was working on StarCraft 2, that's exactly what I would do. And I guess that segues into answering your question. It's like, I think if you have human data, then that puts you in such a good spot for any game that you're working on. Because I think supervised learning, like Timo said, it would just work so well. It's so easy to iterate on your model architecture because it's that you just get this loss function. It's so fast to train. You just need like a few good GPUs, which aren't super cheap, but it's a lot cheaper than like having 100 machines running your game. It's much cheaper than RL. So that's one thing I would say. And then the other thing I guess is maybe try to compare it to similar games, see if people succeeded on similar things, and maybe see if you have the same pieces in place that they did to solve their game. Unless you're an ML researcher, don't try to invent the wheel.
I actually really love that voice. And I think one of the core things, just to put it out there too, is especially in StarCraft 2, I think that is a direction currently that a lot of people are leaning towards, is scoping it out. So not giving the whole aspect of the bot to machine learning, and just maybe either doing unit movements or choosing. The most common one is choosing builds. Builds are done usually sometimes by which strategies are chosen through machine learning. That is probably the most common one, is what we see most. But I like this idea. I'm gonna actually put a pin in it. If no one's done it yet, I'm going to try it on my channel. Anyways, Kyotek, first question, first question someone should, before they get started.
I would, as Vlad was saying, unless you're a researcher or a ML engineer, maybe don't tackle a game that nobody else has tried for your first, especially for your first thing. Do something that has a community around it, with some tools already, with some benchmarks, some people who can support you. That's Rocket League has been great at that. RL Gym has been amazing. The people who made it are much smarter than I am making the gym. And we have a simulator now made by ZLNL that is OptiV2 has actually never played Rocket League. It has only played the simulator. And the simulator is high fidelity enough that there really weren't any sim to real issues at all, because it's 99.9% accurate essentially. So something that has some, if you're a single person who wants to tackle something, you don't, I promise you don't have the resources to make a simulator, to make a gym, to make a framework, to make the learning algorithm work with that game, to do all of it yourself that's a big lift for anybody, especially if you're not well versed in the space already. So yeah, find something that some people have done, especially for your first one, and try and learn the basics. And you won't get frustrated as quickly because you're more likely to get something that actually plays the game. I mean, anyone with any programming knowledge can sit down and make a Rocket League bot that plays the game in a few hours, a day at the most, if you have a laptop or something, maybe, instead of a decent GPU. I mean, I trained OptiV1 on a laptop. It was a gaming laptop, but it was still a laptop. So it is doable.
I think I probably can sum up what you say is like stand on the back of giants. It's just one of those things where it really cuts down. Okay, so now we're going to jump to some questions from the audience. I got a couple in here, and I'll direct them. Some of them are specific and some of them are general. Some JPK314. When making a Rocket League, and this is probably obviously to Kyotech, making a Rocket League bot, it's very easy to make a mistake that mangles the model input, adds weird edge cases to the reward signal or something else, which doesn't immediately fail, but causes long-term issues with success of a bot. Do any of you have stories of this being discovered in development? Okay, this is actually open to anyone, but we'll start with Kyotech, I guess.
So JPK is the one who made my PPO modifications, and he's well versed in all the issues that I've had. But yeah, I mean, OptiV1, for example, didn't know which way was up, and I didn't even figure that out until I was done with it. I figured that out recently when I started making V2. I actually converted it to Rust. And I took the time to actually write tests because Rust has a much nicer test framework than Python does. And as I was writing the tests, I realized, it wasn't the only bug, but it was the worst one in the obs, in the observations. So yeah, there's definitely latent things like that.
Anyone else want to throw on to that question, or before I go on to the next one?
Sure. There were many bugs in StarCraft's observations. It was never complete, and so there's still a handful of observations that should be added but never were. Maybe the most exciting observation bug was when we were trying to add, I don't remember the name of it, like when you start a building but your unit worker hasn't actually gone to start it. Right?
Oh, like a queue, unit queue, or
no. So if your unit is going to start an expansion, right? It will walk. You take it from your mineral line. You say, "Go build a building over there." The unit will walk over there, and in the meantime, at least as a human player, it shows sort of a building, but transparent or whatever, right?
Yeah.
So that you know that something is going to happen, right? So you don't try to expand again, right? And for a long time, these were just not visible, so the agent would constantly send things to go expand over and over and stuff like that. But when we finally added this, it was shown to both players.
Oh.
Yep. And so for a little while there was a sort of a meta where it would start it and then cancel it to try to fake out the the opponent.
I mean, that's kind of cool.
Yeah, and it would just appear, and then it couldn't tell if this was because it was canceled or because it actually started building. And so then the meta changed. The unit would move all the way over there so that before trying to build, so that it wouldn't show this, and so on. Anyway,
Mind
there
games.
were all sorts of these types of bugs, but that was the worst.
Anybody else want to throw in on there? Okay. All right. So next question. This one comes from Rolf, ROLV. Are we cursed to do significant reward shaping? Now, although it opens, it's not specifically added to anybody, but anybody want to throw in there?
So I can jump in there again and say that the trained reward function was super useful in RL. And I guess this is sort of a standard-ish part of RL now, but having the God's eye view that could see both players and what they were doing and take a guess of in human replays, this player has a 60% or 80% chance of winning, gave a much better reward signal than anything we could have done manually.
So Rolf actually made that. He's also in the Rocket League community. He made a next goal predictor that he has used for Ripple, and I've attempted to use a bit for Opti V2, but it haven't had a ton of success yet with just that particularly, especially.
Actually, I'd like to jump in once more and say that one of the challenges of this was that related to human data is that in StarCraft replays, humans almost never finish the game. They resign.
Yes.
And so for a long time, our supervised agent, and actually I guess always the supervised agent and maybe later, it thought its goal was to show off a big army. And it didn't know how to actually finish the game. So once it shows off this big army and says, you should really be leaving now. If the opponent didn't,
Alpha Chad.
it didn't know what to do. It didn't know that it actually needed to try to destroy the enemy's base. And so it could totally lose despite being in a winning position because it didn't know how to finish the game. And so in that sense, some reward shaping might have been really helpful.
Alpha Chad. I love it.
Yeah.
Awesome. Pete or Vlad, anybody wants to jump on that question at all?
Well, I was about to say that you don't need reward shaping if you have human data, but I think Timo just completely shot that idea down. But yeah, I do think I think there is something to that. And I think one thing I need reward shaping for actually is like my bot just once you do the RL point, the RL phase, it sometimes just plays like really, really lame. And just like it'll stall almost forever in some spot, and it's just trying not to die because that's what its reward is telling it. But so basically fixing some stupid things that RL adds in has been necessary.
All right, cool. All right, and then we got from Null PTRRL. Man, a lot of Rocket League boys out in force. Kyotech brings the heat. When can sparse rewards work? Throw it out there to the group. When can sparse rewards work?
When they're not too sparse, I guess. Sparse rewards work, I guess, as long as your agent is able to get them sometimes, like if your random policy or whatever it is, as long as it's able to get the sparse reward sometimes, I think that is like important. Like one way that you can easily eliminate whether the sparse reward is definitely not going to work if it's like something sparse and difficult to achieve. Like if the random policy or whatever your policy, like if it's never able to achieve it, it will obviously never be able to learn anything from it, and that might be obvious when you think about it, but when you're first starting, it might feel like, oh, like I want it to do this thing, but if it just realistically, like I want it to do X, but like if it's not going to ever by random chance be able to do X, that's obviously like way too sparse or just difficult. Something I'll say.
Anybody want to jump on that?
Sure. A sparse-ish but good reward is probably better than a dense bad reward. It's going to learn what your reward tells it, and if it gets no reward, then it won't learn anything. But if you have a dense reward that tells the wrong thing, then it's going to learn the wrong thing. So sparse but good is better than dense and bad.
Love it. Okay. Go ahead.
Just to turn quick, I guess it's the same answer I've given already. Is if you start with a supervised policy, then that really increases the chances that it's going to get that sparse reward, and so it's just such a much better starting point than a random agent.
Love it. And we're coming to the last question. This is also from JPK314. Another, what are your thoughts on changing rewards during training? It seems unavoidable in the case of finite time in order to make a pro level bot, but scientifically it greatly hurts reproducibility. Throw it out there for anybody.
I guess one idea that comes to mind is maybe you could have checkpoints of like, okay, we trained it with this reward and we get this type of bot. And then that's sort of fixed. And then now in the future, we can train different bots from that checkpoint and we can try out different rewards. And so that that sort of makes things more reproducible. So you're not just like, looking at some training curve and being like, I think I'm going to tweak this and quickly restart it. But sort of be like, okay, we have these rewards to train this skill, and then that's sort of like, that's like a known checkpoint that we can now start from in the future. I don't know if you're already doing that.
Yeah, I think you can, and he speaks to it in a second, a little bit there, but you can schedule your changes as well, which is, I do that with Opti. So the first, I want to say 5 billion steps or so are all scheduled. So there's like 4 different reward steps, 4 different sets of rewards for those first 5 billion steps or so, which is about 5,000 divided by 5,000 agents. If I'm doing my math right.
Never do math on stream.
Yeah. So that it is reproducible when I do change something, I can just run that first set and get the same, see what changes. Obviously, I'm not doing scientific things. I'm only doing, I'm not running multiple trials. I don't know if any of us are running multiple trials except Deepmind maybe, because it is just expensive to change something and then run it 10 times. When you can just run it once and go, yeah, all right, that looks good. That probably worked. It at least didn't make it worse. So
that's my approach.
Move on with that. But yeah, I think that's the only thing I've come up with anyway.
So I think one important thing to distinguish here is the reward function from the evaluation metric. So if you want to know whether something is better or not, you need to do actual games where it's win-loss, not can I maximize reward. If you change the reward and train a new agent and it gets a higher reward, is that meaningful? Well, you really don't know because the reward is not comparable. So you really need to evaluate it in win-loss, preferably against more than just itself or the previous one. put against a pool of them. Otherwise, you just have no idea.
Yeah, that's an excellent point. I don't look at my graphs for various things, but I look at my true skill graph a lot, which is my ELO graph that's built into the framework that I use that plays it against all of its previous agents in the pool. So not every single agent, not every single step, but every so often we make a new agent, and those all go into the pool. And if that number is going up, then you feel like something's going well, but it still isn't reproducible against the previous run unless you put that agent into the pool, right? Because the ELO number is only relative to all the agents in the pool. So if that previous agent isn't in the pool, then it still doesn't tell you anything.
It's also worth considering how many evaluations you need to do to get a useful signal. Playing 5 games when the agent and the environment are randomized, does not necessarily tell you anything. You really need to run a significant number of games to get a statistically significant result. At one point, we were spending half of our compute just on evaluation.
Yeah, and I think that's something people can look at in the context of their particular game. How random is your game in particular? Like Rocket League doesn't look very random, but I can put the same 2 agents against each other, and they might win 10-2 one game, and they might win 6-5 the next game, and they might lose 0-10 the next game. It's a lot noisier than you would suspect it is. So you need to do some trials to see how noisy your particular game is, to see how many evaluations are reasonable to run, because you don't want to run, obviously you can run a lot and be very confident, but there is a waste of compute there, and we're talking about trying to save money here. So
Peter, from you, I'm curious, because you have the open world perspective as opposed to us with very specific benchmarks of like players. Anything for you on that idea? Put you on the spot. That's okay. You're muted, I think.
Yeah, on evaluation, yeah, I think, in the case of Pokemon, there are pretty straightforward things to measure. It is interesting in that much like unlike a multiplayer sort of win-lose game, it's not really, ultimately you can beat the game, but it is very multi-objective. So different players might have different goals in the game, and there's not necessarily a correct way to play it. You can talk about just speed running it, but the game's not really just about winning. It's has a lot of facets to it, I guess. So yeah, you might there's not one true objective necessarily. It might be depending on just what your goals are. But yeah, it's yeah.
Cool. Awesome. So we're gonna wrap this up right now. We've gone a little bit over than my limited time, but this has actually been incredible to talk to all of you here. I always, and I say it to anybody, anytime I work on anything video related or guest related, whenever I feel like I learned something, I feel like I had a good conversation. So y'all a lot more accomplished in your bots. My bot has not even, and those who are familiar with my channel, you've watched me come from I would like to definitely say humble beginnings of using ChatGPT to teach me programming into start. So, it's been a very inspirational conversation to talk to a lot of you here. It's been fantastic. So before we wrap up, I would we'll go around the table and get any final points or words of advice from individuals that you just want to sign off with, and we'll start off. We'll go backwards. We'll start from Vlad, and then we'll come back down to Peter. So Vlad, anything that you want to leave, final thoughts you would like to leave people off on with?
Yeah, I'm sad I didn't get to ask Kaio about the replay situation for Rocket League and
No, ask. We
and how
can get in there.
Yeah, I mean, you mentioned a replay based bot, and yeah, I'm curious how that's going. Are those competitive? And anyways, I could probably ask you a million questions. The other thing, yeah, I'd be really curious to hear from Drekken, how your supervised StarCraft 2 bot is doing. Give us some updates.
Well, good. Well, first of all, we'll go with the question from Vlad to Kaio. Actually, we'll use this last part to do that kind of cross question, and that's how we'll end it off. And then I'll give my update. Vlad to Kaio. So Kaio, would you want to chime in on
So Rolf obviously knows a lot more about it than I do, but because it's his bot. But Ripple trained on, I want to say, tens of thousands of hours of human replays, because there's a great ballchasing.net, lots of replays uploaded there from all levels, but I think he only trained on RLCS, so pros and SSLs, if I remember correctly. And it's from the pure supervised learning, it's not very good. It's maybe like diamond-ish level, which is kind of in the middle of the ladder, maybe like top 50%, something like that. But Rocket reinforcement learning does clean that up pretty quickly. But the timing is very, very important in Rocket League. It's all physics based. So there's gravity, there's velocities, there's a lot of things to handle, and the timing of all of your actions is very important. And I think that's the main thing from watching the stream when it's just coming out of the SL. It mainly seems to struggle with the timing of timing the ball moving and things.
Love it. Awesome. And we're actually going to keep this going. I'm curious to know. So Kaiotek, do you have any questions for anybody else on this panel?
I'm curious what size network Peter used and Vlad for your bots, because we're up into the millions of neurons at this point. Opti's like 1 million actor, 5 million critic kind of size. So I'm curious where you guys were.
I'll say, yeah, for Pokemon, at least in the baseline work, it's a very small network. It's literally it's the network from the Nature CNN paper from like way back, which is like a very small CNN. I don't remember exactly. I think it's in the hundreds of thousands parameters. It could be low millions, but it's a very small CNN. I know that there have been folks that have done experiments with larger networks, like the one from like the ProcGen ResNet, I believe, but it hasn't been, none of the experiments that I've seen have shown a dramatic difference with a larger network. I think the small one has enough capacity to remember the things that it needs to know in the scope of that game.
Yeah, and for me, I know my models are 40 megabytes, so I guess that's 10 million parameters roughly. And I haven't played around with the network size in a while, but going bigger than that basically didn't help in supervised learning, so that's where I stopped it. That's a nice thing about supervised learning, is that it's very cheap to play around with your network, with your architecture. Actually, one of the big differences that gave me a big boost this year was I switched to something that's a bit like a transformer, away from whatever I had before, more of an LSTM, and that helped a lot.
Beautiful. Awesome. Let's keep going around for these final round of questions. Timo, do you have a question for anybody on the panel?
Yeah, nothing especially springs to mind.
Did you want to maybe put a question out in the open for anybody to answer?
Sure. Are you going to do a different game? And if so, which one?
Ooh, I like that. That's a good one. Oh, the floor for anybody?
I'm probably not going to do it, unfortunately, because, well, anyways. But one thing I was thinking of that would be so fun is competitive Pokemon, because I've been watching a lot of competitive Pokemon. I don't know if any of you know about that, but I think it's such a, because that's like the most RPS. That's way more RPS probably than even StarCraft. Like literally every move is like, oh, are they going to stay in or are they going to switch? Should I use the super effective move against the guy they have in, or should I be switching? And like there's all these mind games about like disguising what moveset you have, and I think that aspect. I was starting to get interested in the context of Smash Bros, but the aspect of playing like the mind game, which I think is a whole nother level, beyond just like the mechanics and the control. So I think that'd be sick. I don't know if anyone's working on that.
Anybody else for games? Sorry.
I still have a long way to go on Rocket League. I want to beat pros in all three modes, and I think I'm maybe there in 1v1, but to be seen still. I'm not there in 2v2 or 3v3 yet, but StarCraft 2 is definitely on my short list, because there is that community. There's a lot of tools already, and it's an interesting game. And H, who one of the guys who made RL Gym, says that there's really only one problem in reinforcement learning, which is exploration versus exploitation. And you have a lot of exploration issues in StarCraft 2, which I think would be interesting. You have them in Rocket League as well, because the gravity keeps you on the ground, which makes it difficult. But yeah, it's StarCraft 2 is definitely on my short list. I don't know if that's where I'll end up, but it's on the list.
Anybody else for a different game? Peter, is Pokemon where you're going to stay forever? Well, you're obviously doing a lot of other stuff, but would you try another game?
Actually, in the last year, I've been building my own game, actually, which is it's kind of like a large scale ecosystem simulation game, like lots of like physics objects kind of environment. And one of the sort of long-term goals for it is that it's designed to be really good for things like reinforcement learning and like evolutionary kind of algorithm stuff. So I don't think it will be in that phase for a little while still, but that's a high level goal that I would like to shoot for with the project.
I love it. And I'll actually throw it in there. I've only done StarCraft 2, but I have to always be careful not to do shiny object syndrome, where I just jump in from one project to the next. But Brood War has caught my interest. I have always like Brood War looks so tempting to work on. And then Street Fighter. I actually was going to reach out to someone who actually made a Street Fighter 4 bot, and I was curious about Street Fighter. Like, just a little bit of background for me. I actually come from the arcade eras when it comes from gaming. I would say I played competitively, won my locals, whatever. So Street Fighter hits home. Like, I was a very arcade rat with the quarters. So making a bot for Street Fighter or chess definitely is tantalizing for myself. But StarCraft I have a very long way to go for there with StarCraft 2. And then Peter, do you have a question for anybody else on the panel? And we'll round that out with my update.
I'm curious, Timo, what you've been up to since the AlphaStar work. What kinds of things you might have been working on?
So I spent a year working on controlling a fusion reactor with reinforcement learning.
Okay. I'm familiar with that.
Cool.
Yeah, so that one we trained in simulation, then ran on a real plant, got a Nature paper out of that. It was really cool. Turns out that defining the reward and figuring out what you actually wanted to do was really hard. That was my biggest contribution to it. And then I spent a 2.5 years on weather prediction, and then did some hiking. So.
I love it. It's like fusion, weather, hiking. It's actually super fantastic. I love it. So that's cool. So that's our panel. And so to round it out, I was asked what, where's my bot at and what's my situation. And so just before we go, I'll comment on it. So this panel is very selfish of me, because I have been trying to, like, StarCraft 2, and every time I've been talking to people about doing reinforcement learning and even machine learning in general with StarCraft 2, people have been like, it's impossible, don't do it. And that's kind of like the general words of wisdom in our community. It's like, it's too hard, it's too difficult, don't try it. I'm determined to personally move it forward. There are people who've done it, and there are some in our community who've tested it, but they've come in and say it's too much. So having you guys here was a little bit for me to draw ideas for our scene on how we can come at it from a different angle, and if there are different methods that we can approach it. I will say right away, as a summary for all this, is scoping it out. We just finished our micro ladder, so it really just brings the game down to just micromanagement of a few set units. Like you get X amount of units and it goes rounds, and it's just different units. And then for me, my hope or my plan is to, since it makes the game a lot smaller, working on just the micro arena and working with some supervised learning. That came as an idea from talking to you guys here. So, I have my bot. My bot is completely scripted. It's scripted, deterministic, straight from up to bottom, but I've been super interested. I have a lot of resources from people who've worked on it. A lot of people have just put together a lot of projects and stuff, and they've just left it. PySC2, obviously, Timo's out there, but no one really touches it in our scene. So I am determined to make use of these tools that have not been used for a while, and try to really kickstart the exploration back into reinforcement learning and machine learning back in StarCraft 2. So back to you, Vlad. That's just and I'm going to start hopefully next year into the just specifically micro and only micro, and that's how I'm going to scope it. That's my plan.
Just as a plug, PySC2 is open source, but so is AlphaStar, almost all of it. So if you want to try the hard thing, you can.
Yeah,
it's so hard.
I might take it again for pieces to learn from. All right, so that's our panel. We went way over time, but I thank you so much all for giving me your time and being here on this panel. I really appreciate everyone contributing their ideas and discussions. This is the first time I ran this panel ever, and I'm hoping maybe we'll have an annual version of this where we are able to get back together and other games. There are a lot of games out there. Chess, obviously, I reached out to the chess group there. There's a bunch there who worked on Stockfish and whatnot, and grab other games to have those kind of conversations. So thank you all there. Thank you those who watched and stayed with us. Really appreciate it. I want to thank Vlad, Kyotek, Timo, and Peter for being my guests. I really appreciate it. And for those of you who are subscribers of the channel, tomorrow is the grand finals of ProBots, StarCraft 2 bots, where we get to see basically the end of our season for the year. So make sure you tune into that. And other than that, I will also have, for those who have projects, GitHubs here in the descriptions, so you can see out their projects, see what they're going on, and or if there anything that they want us to see, if you want to follow them in their various projects, those will be in the description or the pin tab below. So other than that, thank you all so much for watching, and see you next time. Happy coding.
Thank you.
Thank you, everyone.